Assalamu alaikum. This is chapter 2. It's about evolution of the major programming languages, in which we will cover uh, a wide range of different names of programming languages, their evolution, and their historical background. So we're gonna start from the early programming languages like Plankalkul, developed by Konrad Zuse from Germany. Then we will go over the minimal hardware programming language like pseudocodes, like shortcode and long code. Then Fortran. Then the functional programming, starting with Lisp programming language. Then we're gonna go towards first step towards sophistication, in which we're gonna talk about ALGOL. ALGOL has a lot of versions, so we're gonna go over briefly over some of these versions from 1958 to 1968. Then the computerizing business record, which is COBOL programming language, which is specialized for business. Then the time sharing, starting from basic language. Then there is PL1 language and two early dynamic language like APL and Snowball. After that, since early or late 1960s, we're gonna start with data abstraction language like Semiola, which has a lot of versions as well. Then the orthogonal design starts with ALGOL 68. As we said, it has a lot of versions, but these versions, they are differ slightly in the syntax and also their features. After that, we're gonna touch bases with some early descendants of ALGOLs, and then Prolog and Ada languages. Our topic also covers the object-oriented programming language, starting from Smalltalk, and then we're gonna talk about combining imperative languages like C++ and object-oriented programming languages like Java, C#, .NET, and then ending at what we call programming hybrid languages or markup language like XML and HTML and so forth. So here is a picture or an image showing the evolution or the historical listing of these languages. Let me show it here bigger. In this one, you see that they're starting from 1957, 58, all the way to 2015. And they put here Fortran in the beginning because Fortran is a language that has been working and with new version every time from 1957 all the way to 2015. They have this latest version. But other languages, you'll see them here spread in according to the years they have been developed in them, like common Lisp here, which was designed in the mid 80s, and C++ also in the mid 80s, and then Ruby, it is PHP, has been developed 1994 and so forth. So this is a list of a lot of languages, more than what we're going to talk about in this chapter. They are all listed here in this image to show you when every language is created, just to give you an idea of the timing or the historical background of them. We're gonna start with Plankalkul. As we said, it is created by Konrad Zuse from Germany between 1942 and 1945, but it has never been implemented, and that's why you don't see this language listed here in this list of language. It has never been implemented. It didn't find any commercial support, but the reason why they are listing it as one of the very first and important programming languages, because some other language has been designed by taking some features from this language, because they have advanced structure, by the way, floating point, variables, arrays, records, and so on. So this language is one language that some syntax is very complicated. Like this is, for example, is going to be an expression, assigning an expression to a variable, in which you will see some numbers mixed with characters and so on. So it has some sort of advanced level of structure. Maybe that is discourage people from using it as a language, so people start designing new ones. The pseudocodes start with a shortcut which is developed by Mockley in 1949 for computer systems called BNAC, and the expressions are also some sort of complicated or unreadable, so it has really poor readability, and expressions were coded from left to right. So these are examples of operations. So if you'd like to represent a plus sign, you have to use 07. If you would like to use an equal sign, you have to use numbers like 03. So all exponents, power, root, all these functions are expressed with either numbers or combination with numbers and characters. So for example, if you'd like to open a parenthesis and put something inside it, so you have to use this one, 09 first to open a parenthesis, and then 02 to close it. So it's some sort of poor readability and also poor modifiability. So it requires very minimum hardware programming, but expressions coding was very tedious. It has no indexing or floating point variables and stuff like that. This is an example. For example, in order to write an expression like 7 plus 2 equal 9, for example, you have to use a combination of numbers like 7 plus we use 07. So 2, this is 2. Okay, so 7 plus 2 equal, because 03 is equal, as we mentioned earlier here. 03 is equal. So here, for example, 7 plus 2 equal what? Equal 9. So if you use a number by itself, is a number, but if you use 0 as a number, then it is an operator, and so forth. So it has no some sort of operators in the sense of operators, but they use digits for that. And Speedcode comes after shortcode, which is developed by Backus in 1954 for IBM 701. IBM 701 is a machine, is a computer, which is, like what we see right now. We have like HP and Toshiba and stuff like that. So this is IBM 704 at that time. There is no other computers, hardware at that time, 1950s. So the Speedcode was developed by Backus back in 1954 for IBM 704. And it is actually designed for arithmetic and math functions, basically. It has been designed with some sort of constructs to accept conditional and unconditional branching, and then also they have like automatic increment for array access. It is very slow, one of the features, and then also it allows for certain number of words, which is like 700 words left for a user program to write. 700 words per program, which is also some sort of weakness in this language. In Pseudocodes also has what we call related systems, like UNIVAC compiling system, which is developed by a team led by a lady. Her name is Grace Harper. This lady developed this lady, Grace Harper, is American general from the American Army who is specialized in computer science, and she is the first lady to use the term bug in computer science. She developed by a team led by this lady this UNIVAC compiling system, and they expand this pseudocode programming languages into machine code. Also in Cambridge University, David Wheeler developed a method for using blocks in languages to solve problems of what we call absolute addressing. This is part of related systems between high-level language and machine code. IBM 704 and Fortran. It's a relationship between 704 from IBM machines and Fortran as a language. As we will see here, Fortran 0, which was developed in 1954, it has not been implemented. So it has been kind of put aside, some features taken from it to develop Fortran 1, which is 1957. So I would say that Fortran 0 is just like a starter for designing this Fortran. Fortran stands for Formula Translator. So they call it to translate the formula, i.e. to compile a formula to get something out of it. So it's called Formula Translator, but the short name for it is Fortran. 1957, the first one that was being implemented. So they designed it for at that time was a new IBM 704, which has a lot of different hardware functionality for index registers and floating point and stuff like that. So this is the first time people start thinking about the idea of compiling programming languages, because the cost of interpretation has been minimized, and there was no place to hide the cost of implementation. So because there is no floating point software. At that time, the environment of development, computers were small and unreliable, of course, and applications were very scientific, and no programming methodology or tools has been in the development environment. People, they start thinking about machine efficiency more than the application efficiency. So because machines were so slow, memory was so small, and computers were not fast, so machine efficiency was important concern at that time. Not like now, where people, they don't really focus on machine efficiency, because machines are efficient anyway, and also their memories are so high, big memories, big hard disk space, and so on. So the design process of Fortran, it had an impact of environment on design, there is no need for dynamic storage, and It needs good array handling and counting loops, no string handling or decimal arithmetic, and or powerful input output for business software. So there is some concerns of the Fortran 1. Of course, they fixed all that weakness in the next versions, and but every time they discover new weakness in a language, they have to make it up for the second one. So the first implementation version of Fortran, you can notice from that version that names could have up to 6 characters only, and there is post-test counting like do loop, and they have also input and output statements, and user defines some programs, subprogram is sub-functions. There are three-way selection statement using arithmetic if statement, and there is no data typing statement in the first version, and also there is no separate compilation. So compilers were that were released in 1957, and they require a lot of work in order to release these compilers, and it is very difficult to compile larger programs that are larger than 400 lines can rarely be correctly compiled. There might be some sort of difficulty compiling big programs, and this is because of the poor reliability of the machine itself. I'm talking about IBM 704 machine, and after that it became widely used after the compilation implementation of the code. Fortran 2 has been distributed in 1958, and it requires independent compilation, so they created a separate compiler for them. They fix all the bugs and weaknesses that has been found in the first version. Then this version 4 evolved between 1960 to 1962. It has explicit type declarations, and they have logical selection statement using if statements. Also, subprogram names could be parameters, so they can actually have functions and methods as parameters. And they are also first time to use ANSI standard in 1966. ANSI, which is stand for American National Standard Information Code, that has been developed by the American National Standard community, or it's a standard that is known by ANSI, but it is used all over the world. Fortran 77 became the new standard in 1978. It has character string handling. Also, they use logical loop control structure, different types of loops. Also, the first introduction of if then else statements into that version. Fortran 1990, it has more significant change from Fortran 77 because it includes modules, dynamic arrays, pointers, recursion, and also introduction of case statement. And for type checking, which has already been implemented in the previous versions, this one has parameter type checking. So type checking is done for parameters as well as for other variables. The latest version of Fortran, like Fortran 95, Fortran 2003, Fortran 2008, and so forth, they have witnessed some minor additions and some deletions from previous ones, but they generally support object-oriented procedure pointers, and also has been integrated with some language like C programming language and so forth. If you like to evaluate Fortran, I would say it is highly optimizing compilers. All versions before 1990 are highly optimizing compilers. Also, the types and storage of all variables are fixed before runtime. So before runtime, these variables has been placed into memory and saved into storage locations. This Fortran is very important language because it dramatically changed the way computers are used forever. This is program code in Fortran. It uses some code similar to what you see in other languages. It has statements. It has assignment statements. It uses comments here, like you're using exclamation mark for comment. This exclamation mark at the beginning of the lines, that means every line that you see has exclamation mark. That means it is a comment line. And it has some initialization, like here result equals 0, sum equals 0. Read means input from the keyboard, and here it uses logical statement like if statement. If, and then between two parentheses you will find an expression, and then you find and then another expression, and then the word then. So if this is true, then read means input data into the array and compute it, and so forth. And then here after if you will find also do counter, which is a loop, and to end the loop as well. And then there is another loop here, and then there is a nested if inside the loop, as you can see here at the end. You will see the if statement. Every if statement end with end if, but this is all inside the loop, and then the loop end here. Then this is a comment line, and then this is a line to print. Print means display to the screen, not sent to the printer, but they use the command print. Else print another thing. End if, and then end program example. So this code, the two slides represent a code from Fortran latest languages. So if you can copy an example of a code and can run it in a compiler, online compiler, to see the result of this program, that would be helpful. Then after that, the functional Lisp functional programming language, which is Lisp programming or processing language. It is actually, its name is Lisp processing language. So the name for it has been short named as Lisp, Lisp. It was designed by MIT, by McCarthy. MIT, it is a very recognized educational institution in the United States. Massachusetts Institute of Technology, which is now #1 in science, in all types of science, especially engineering and computer science. Artificial intelligence research needed a language to process data into lists rather than arrays. So they use some symbolic computation rather than numeric computation, and they have only two data types. These are atoms and list. So the syntax is actually based on what they call it lambda calculus. So the lambda calculus is actually a formal system also, in mathematical logic for expressing computations. This is actually based on function abstraction and application using what we call variable binding and substitution. So it is a universal model for computation that can be used to simulate any machine. It's called lambda calculus. The representation of two list is like this. So you will see like lines like dominoes representation. So if you would like to represent the list A, B, C, D, and also A within bracket and B, C within an inner bracket, D outside the parentheses, I mean not a bracket, parentheses, and then E within a parenthesis, but EF inside another parenthesis. This is the representation similar to this analogy, as you could see here. So it is those of you who actually studied data structure would be able to understand some analogy of this representation of the Lisp programming language. So Lisp Evaluation, it is a pioneered functional programming language. There is no need for variable, no need for assignment, and the control of it will be through recursion and conditional expressions. So it is still dominant language for artificial intelligence. These two languages called Scheme and Lisp, I would say they are contemporary dialects of Lisp, which is this common Lisp. Common Lisp is a version of Lisp, and also Scheme programming language are some subversion of Lisp, and they have very different syntax, like F#, but they are used basically for what is called logical and abstraction to represent simulation for machines. And Scheme, as we did talk about it earlier, Scheme is developed also at Massachusetts Institute of Technology in mid-1970s. It is a small programming language. It is very extensive use of static scoping. So they use a lot of static scoping, and they use functions like first class entities, function or methods. It has symbol syntax and also very small size as well for programs. So this is why it make it very ideal for education application. So people use like C programming language, for example, although it is not used widely in the market, but people use it basically for educational purpose. So Scheme is one of those languages that are used for educational applications. Common Lisp, as we said, it is a feature of different dialects of Lisp, and then to make it very large and complex, so it is used for industry for some large application. So Common Lisp is a kind of another version or a more advanced version. It has a lot of different several features added to it from the original Lisp language. We come here to the first step toward sophistication. We start with ALGOL 60. At that time, the environment of development, it has actually been dominated by Fortran, and many other languages were being developed at that time for specific machines, and there was no portable languages. They're all machine dependent, so that you cannot actually install a language that had been created for IBM 704 and install it in a different computer. So there is no portable language. In the other words, all languages that have been created, they were created as machine dependent. They depend on the machine that they is created for. So there is no universal language for communicating algorithm. So ALGOL 60 was the result of effort to design a universal language. So what you need to know is that because there is different languages and they are all machine dependent and there is no portable language, ALGOL 60 was developed to represent a design that it is universal and common for different machines, no matter how different from another machine. So these representative from ACM and GAMM companies, they met for some days between May 27 to June 1st, 1958, and they started making some agreement to create such a language. They agreed on the goal of this language is to be close to mathematical notation, so it is more mathematically oriented, and also they decided to make it good for describing algorithm, and also must be translatable to machine code. So these are main three goals of designing the ALGOL 60. So as you could see, ALGOL 60 has been set up to start, or the meeting to design it has been done in 2 years before its development in 1958. Because ALGOL 59, some features of it has concept for types was very formalized, and also the names could be of any length. Arrays could have any number of subscripts. Also parameters were separated by mode. It has in and out, input and output, and also subscripts were placed in brackets, and compound statements, they have to start with begin and end with end. Also semicolon, it is a statement separator. You have to use semicolon to separate the statements, and then they have to use assignment operator colon equal instead of equal. And also every if had an else if clause by default, and there is no input output, which is to make it machine dependent. So this is 58. In implementation of ALGOL 58 was not meant to be implemented, but it has been created to be tested for different applications by IBM company, but they dropped it by mid 1958. By mid 1959. We'll talk about why there is a need to create ALGOL 60, because 1958 ALGOL 58 has been suffering from all these drawbacks. So in ALGOL 60 overview, we can say that it modified ALGOL 58 after 6-day meeting in Paris between these two designers from these two companies. We did talk about them, which is ACM and GAM. So the new feature of this ALGOL 60 is that it has block structure, local scope structure, and also two parameter passing methods. The previous one, it allows for only one parameter passing. It has also subprograms, recursions, functions and method recursions, and stack dynamic arrays as well. Still, there is no input and output and no string handling in ALGOL 60. The success of this language, because they made a lot of change to it, so it was made the standard way to publish algorithm for over 20 years, because all subsequent imperative language are based on this ALGOL 60. So it made a lot of difference in computer field, and it could be considered one of the first machine independent language. Independent means the language can be installed in many different machines, and one of the language that could be also its syntax was formally defined in BNF, or the first language whose syntax is defined in Bacchus Naur form BNF, as we will explain in chapter 3. But there is some drawbacks of this language, we call failure that happened for this language. It has never been widely used, especially in the United States. What are the reasons? The reasons are lack of input and output statements, and also the character set. It made a program non-portable. So the character set, because each language of course has a character set that has to be met, or the properties that has been created for the language, they have to be in a specific character set, like character TF8, something like that. It has to be made for a language so that it can work in any different computers that have different character set. So it lacks this feature. It was very hard to implement, and also it has suffered from some interchangement of Fortran drawbacks or shortcoming. It has also formal syntax description and lack of support from IBM. Lack of support from IBM means this is in its meaning that IBM does not support it financially, so it doesn't find financial support or commercial support. So if a language that has been published in 1960s or 50s or 70s without an IBM support, they will be regarded as failed programs, because IBM was dominating the market. IBM is the first and the largest company to produce machines for programming languages. So if IBM does not support a language, that definitely means the failure of this language. So I wouldn't say it's a failure, because we said it has success as well, but we will say that it was not widely implemented as it has been expected at that time. So I will stop this video here, and then in the next video I will continue with computerizing business records, in which we're going to start from COBOL programming language.